Hello, everyone, again. We are
Hello.
here with another amazing topic, geospatial solutions for resilience in natural disasters. And we have amazing guests. Let me introduce at first Sarat Raj, Project Director, Amity Dubai Satellite Ground Station and AMISAT from Amity University, Dubai, and Mustafa Quaik, CEO of Space Guardian, Merve Faruk, Managing Geospatial Consultant, Ordnance Survey, and Sona Gulieva, researcher in urban and regional development, Politecnico di Torino. Welcome all again. So let's start.
Hello everyone. Hi Emre, and thank you for introduction. And thank you so much. It is a pleasure to moderate today's session about how geospatial technology shape disaster resilience. And we have a panel of great experts in from various backgrounds. And let's start with our first discussion point. Today, in a world with increasing number of disasters, natural disasters, geospatial tools are more critical. And I would like to start with the first question: and how are geospatial tools revolutionizing the detection and management of geohazard? Maybe I will start to address this question to Mustafa. From your experience as a GIS and AI expert, how do you think geospatial technology, especially with AI-driven solution, improve disaster prediction and response?
Yeah, thank you, Sanat. So the thing about geospatial tools is a wide term that goes across many definitions. There's technology, there's science, there's cartography, there's art, there's a lot of aspects that goes into that specific term. And when we think about geospatial stuff, especially geospatial tools, we need to take all those considerations into account. And like, and just to answer your question about how geospatial tools can help in disaster recovery and resilience. Also, we need to project and map those terms from science, technology, and art into three different categories. The main categories into disaster recovery is preparedness, which is planning, which goes into simulations, gathering data, situational awareness, and the second part is when a disaster happens, when critical stuff happens, we need to act, we need to understand where do we stand. And unfortunately, in most of the cases, we don't know where the disaster will strike. However, we might collect some information before, during the planning stage, but in mainly most of the cases, we don't know when the nature will do its thing. So that brings us to another domain where we need to gather more information in real time. But at the same time, we don't necessarily have all the tools that will generate those real time information into our systems, into our geospatial systems, let's say. And the third part is how do we recover? And this also will bring us to again to the same activities that we might be doing during the planning stage, which is reassessment and comparing before and after situations and scenarios in order to understand the size of the disaster, the size of the impact that we have after an event that happened. And if you think like what are the tools, what are the systems, what are the things that we need to do across all these three domains, we need the most. I believe the most important tool is a geospatial tool, or let's say geospatial systems, not only tools. And I think because it gives us different perspective on interpreting and understanding the situation from the information that we can collect. But the most important thing is the location, which is very important and very critical in these situations.
Thank you so much for sharing your insight. And so, geospatial technology together with AI is so important tool to consider in all stage of disaster management cycle. So, if you have any additional comment, Marwa and Dr. Sarat, I would like to ask you. Maybe to start with the Marwa, from your work at Ordnance Survey, have you seen how geospatial data effectively used maybe in national disaster resilience strategy today? Like maybe you can share.
Yeah, thank you, Sona, and
Thank you.
thank you for moderating this panel. And it's a pleasure to be with my colleague panelists. So whenever we talk about geohazards, the first thing that would come to my mind, according to all the practices we have went through in different in ordnance survey or in previous work, is the risk assessment and mitigation. This comes usually before the early warning system. So in the context of disaster management and risk mitigation, start first where you involve proactive measures taken in advance of any specific threat to reduce the overall threat, to reduce the overall risk. So, and the outcome of this will be something like suggesting levees, for example, to prevent flooding, or reinforcing building codes to make sure that the building can stand or withstand earthquakes. In this phase, usually it is geospatial technologies that facilitate comprehensive risk assessment by integrating various data sources, whether it is topographic maps, climate data, historical hazard records, all of these, the power of integration, overlaying, and doing analysis on different data sets coming from different sources. This indication or this integration helps us identify high risk zones, and according to this understand the possible impact and start taking some policies or strategies that can reflect in national building codes or in national strategies to mitigate the risk. There is a lot that can be said on the early warning systems. A lot of risk knowledge should be there, and monitoring and predicting when the risk will happen and so on, until the dissemination of information. All of these can leverage the capabilities of geospatial technology. Um, Another bit that sometimes we forget to talk about is community engagement and education. So now maps are quite easy for people to read and understand and comprehend. Geospatial tool can play a big role in educating and engaging communities about geohazards, about any type of hazards. I would say it's not only geological hazards that can leverage geospatial technology to mitigate or to manage. It's different type. If you are talking about air quality related hazards, it's biological hazards. All of these hazards, they happen in a space or in a place, so they are definitely a potential to be supported or managed using the geospatial technology. So again, the awareness, the community awareness bit is crucial. It will foster the culture of building community resilience and make sure people are prepared to respond and recover from disasters. Like my colleague said, the post-recovery phase is quite important as well. And in this part, we can leverage high-resolution satellite imagery and aerial surveys. The presence of high quality data that is recent, up to date, will help in evaluating the extent of destruction and identifying where exactly you need immediate intervention or immediate attention and so on. Even after this, when you are talking about reconstruction plan, ensuring that wherever building efforts you are putting it in a less vulnerable area and a place that is less exposed to risk. So allocating and identifying where the rebuilding or reconstruction activities should be as well can use the geospatial technologies in it. So yeah, thank you, and passing to Dr. Sarah.
Thank you so much. Thank you for so detailed answer and for I totally agree with the point of that it's critical to make awareness. And thank you. And Dr.
Thank you.
Sarat, you have a background in aerospace engineering. I am just wondering, like, how do you think, like, today's satellite technology, like the existing satellite technology, how it's evolving for real time, like monitoring of the disaster? What is like today's current situation regarding to satellite technology?
Thank you, Sona and Engineer Mawa and Mustafa, for being in this panel. And it's my pleasure to be here and to discuss about the geospatial technologies and its application in the real-time world. So, as Engineer Marwa has clearly mentioned, and I resonate what she has mentioned. The risk assessment is something which is basically we will be looking at it the early stages of the before the early warning systems. And I would like to bring up the aspects of machine learning technology as like AI technology, which has been integrated into the GIS currently. So for the early warning systems, we can basically looking into the ground deformations and land anomalies, or you can say the atmospheric anomalies which we are using. One is the LSTM, that is the long short-term memory network networks, which can be easily deployed to get the early warnings. For flood susceptibility, we can use that. In terms of risk assessment and mapping, I prefer to go ahead with the YOLO. YOLO is the you only look once network. That is also one of the newly developed network systems which can be employed. And in terms of what do you call it as the disaster response systems, where we basically use the random or the forest one or the fire trees, which we can be basically employed, and we can get the data from the data very easily. As well as for the post recovery, what she has just mentioned, it is very, very important, because we need to understand that how much is the affected area, how we are planning to go ahead with the urban planning, and for this aspects we can use the integration of convolutional neural networks for image segmentation and classification. So that is basically helping us to do more in terms of spatial management as such in general. So in terms from the early warning system, then the risk assessment and mapping, then we go for the disaster response systems, and then we go after the recovery. So there are different ML tools which are basically available currently. And as Mustafa has clearly mentioned, we need to educate the society on the requirement and the need of these geospatial tools, because the government authorities are needed to train the officials into these technologies, so that the response rate and we can reduce the latency on the aspect of any kind of a disasters happening in this world. That's my take on the first aspect of improving the or addition of AI into the geospatial management aspects.
Thank you so much. And I think we can move to the second point regarding to the like happened one of the disaster 9 months ago in severe flooding, and which highlighted the critical role of geospatial technology. So I would like to just highlight this event and how the role of geospatial solution has been highlighted in disaster preparedness and response. And I would like to address a question to all of you, and how could satellite and also at the same time aerial imagery can be used more effectively during this event? I mean, like, what lesson we learned from the severe flooding in Dubai, and how geospatial technology used? And have you faced any notable application or any successful case study in recent months, and including the example of Dubai flood?
Just also to the first topic, like yes, like geospatial tools are a lot, not a lot. Like they are very very, and you can use a lot of methodologies. You can use a lot of techniques. And when we talk about the satellite technologies, where it brings us to Earth observation um, aspect, the domain of Earth observation, this is one of the I believe most interesting things that we can that people and the countries and the investors are developing in recently in our, at least in our region in the Middle East. We've been seeing a lot of activity, lots of initiatives in that domain. The community engagement and community awareness is a big thing, is a big topic. We know that there is a still gap in the skill set of the people in our region in terms of remote sensing, image processing, AI, artificial intelligence, but there's a lot being done. And just to jump into your next question, which is the Dubai flooding that happened last year. So in terms of what we did as like Space Guardian, we had a very successful use case in that domain. We helped identifying during the event where are the water bodies forming using different AI modules, and by collecting also imagery data from different data providers, from satellites. Um, we didn't do aerial imaging, but this is another thing very useful in doing so. So what we were able to do is identify the change detections, but moreover, just to go one step inside that change detection at a larger scale is to go and identify what are the changes that happened and classify those changes into categories. And in that case, it was water bodies that were forming because of the rainfall. Uh, and during that event, we were able to I won't say generate information in real time, but it was almost near real time to understand what's happening on the ground. But that's not enough. Actually, we go back to what Engineer Marwa and Dr. Saraf mentioned. Risk assessment was very critical in that stage in order to compare between what's going on now and what we did have before the disaster happened. So we were able to generate not what if scenarios, comparing scenarios before and after, and at the same time, this information was used to mobilize the emergency response teams on the ground based on what we are gathering. Um, just I want also to mention that it was a really uh, because we read the news. I live in Saudi Arabia in Riyadh, and we read the news. It was really impressive how the government can deal with those critical situations and the response aspect, but at the same time, and after the disaster, and how they were able to help people in very residential areas. And talking about also residential areas, the AI model that we used where I just wanted also to highlight that the AI module was able also to detect the land use, whether those are commercial, residential areas or greenery areas, and that helped a lot in order to identify where are the critical areas that needs high priority in the response stage to save lives. And that's where it's very critical to use such technologies.
That's very interesting point. I am just wondering, like, with the spatial planning, if it will be possible to predict the flooding, like, to make it much more, like, to 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 be prepared for this flooding. What do you
More
think
active
about?
stage. Yeah, yeah.
Maybe.
So
Yeah.
to answer your latest question, so definitely yes, it is possible with some machine learning models and looking at historical data to understand or assess where are the possible coming events that will take place and what are the vulnerable areas to flooding. I love the question, but for me this long question is like 3 in 1. So talking about Dubai, uh, during the flooding or before even that, Dubai did establish a very sophisticated control and command center that involves collaboration between Dubai Police and Roads and Transport Authority and Dubai Municipality. This center leveraged geospatial intelligence big time, big capabilities, based on the technology was there to enhance the city operation and disaster management with all these 3 agencies on board to manage the operation. I wasn't part of it, although we have been working with Dubai Municipality for a long while, but I guess all of us in the region, we have heard about this. In theory, when you are talking about a control and command center concept, it is using the real-time data, integrating the real-time data that are coming from different sources. If we are talking about updated satellite imagery that they have access to, or aerial surveys that they could conduct with drones or with something else, or even ground sensors, all these cameras or sensors or IoT devices that you see in the streets, these are all bringing real-time data. So just imagine bringing all this data from different sources in one city operation room with monitors, servers, machine learning models, and amazing, brilliant stuff on board to try to manage the crisis immediately and allocate resources according to this. real-time monitoring capability is very important and very critical to detect and respond to an incident promptly. Data integration is a complex part that is managed or is can be addressed using geospatial technologies, and again predictive analytics, which you were mentioning. If we're talking about how these capabilities can help geospatial in intelligence play a crucial role, if we are talking about before the event, for example, if you have high resolution satellite imagery and remote sensing data that can come from drone, aerial, or whatever, this can be used to monitor weather patterns together with the weather data that you have, identify the flood areas, and issue timely warnings to prepare all organization and community to take preventive or protective measures. During the event, real-time imagery that are coming from drones or other IoT devices can provide a comprehensive view on where are the affected data. We can even talk about sensors that are in street that might give you some information about the level of water, how much is this flood has reached, and feedback to the operation room. After the event, like my colleague Mustafa was mentioning, like having satellite imagery of before and after is incredibly brilliant to understand where the changes took place, where is the damage concentrated, and act or plan your action according to this. If we're talking about lessons learned in general about what happened in after any flooding event, I wouldn't say only Dubai, but for any city, it's crucial to understand how the timely and accurate data is needed. You need detailed data on everything and up to date about the building heights, about the elevation of the roads, how high the roads are, how connected they are to understand the flow of the water and assess the possible damage. To run comprehensive risk assessment before getting into a risk or into a geohazard or any other type of hazard. So we have to try to be all the time proactive rather than reactive. And a big chunk of the work and saving our resources and our assets is being prepared with the risk assessment. And then effective communication. Geospatial technology, like other, can facilitate communication, communicating to people where are the blocked areas, where is the more affected areas, and so on. So it's limitless when you are talking about how technology can spread the word. If your third part is about what we have been working on in earnest survey related to geohazard assessment or management and so on. So I would say that smart cities and digital twin is a big thing. So at Ordnance Survey, we had been working for many years with Dubai municipality on various programs related to supporting and empowering the implementation of Dubai digital twin, which I guess everybody knows about. Why digital twin? The concept of smart cities and digital twins is revolutionizing disaster management and many other areas. A digital twin, as you know, is a virtual model of a city, integrating real-time data from various sensors or IoT devices or others to create a real model of what is the city like now. Okay, so if we talk about this, and it's important to simulate the risk of any hazard, flooding or others, you are having a copy of your city on the machines. You want to run risk assessment or visualize, simulate risk. You run it effectively. You understand the risk. You are really ready for it before it happens. We have also worked lately with in Kinshasa, in DRC, Congo, which focus on flood protection. This is a current project we are happy to work on. It's related, or it's about disaster risk reduction related to flooding, especially in connection or in collaboration with local authorities. We are trying to implement a series of measures to mitigate flood risk. This includes identifying vulnerable areas. Where are the most vulnerable areas? Like again, my colleague Mustafa mentioned, identifying where are the land use distributed, where are the critical infrastructure, where is the green space which has a big and good role in absorbing and mitigating the risk of flooding. So all of this is part of our work in DRC Kinshasa. The third project or the third case study, it's a little bit different. It's related to the financial sector and disaster assessment or disaster understanding. This is a study that we did for the UK Space Agency, and it leverages geospatial intelligence, or it tells the financial sector how they can leverage geospatial intelligence to protect and evaluate the assets by integrating satellite data and other geospatial data and information into financial decision making. This approach will help in assessing or understanding the value of the asset, the possible risk which directly influence or impact the financial decision. So yes, in summary, the integration of smart city technologies and digital twin models and spatial finance is transferring the disaster management from different perspective, from the municipal to the crisis management to the financial sector. Yeah, it is. Thank you, and passing to Dr. Sana.
Thank you so
Yeah.
much. Thank you for sharing too much detail and for mentioning too huge amount of the work what you are doing. And I, I would like to ask also Dr. Sarat and
I echo Dr. Engineer Mowa, and basically this, and being an academician, I can see that what they have mentioned in a segmented way, by saying that how it's happened in the pre-event and during the event time, and what is the flood susceptibility and flood extension, and then how these federated learning approaches. So that is what Engineer Mowa has mentioned about. Accommodating with the RTA, accommodating with Dubai municipality and different first responders. So that is a federated learning approach by having different types of remote sensing data, whether it could be in the form of aerial data or satellite imagery, that could be used for transferring the information to the first responders who are actually on the grounds where the flood is there. So that federated approach is what basically Dubai has taken, and we have success stories to mitigate these flood in very approximately within a week time. We could able to regain the original roads and other things. However, I would suggest that we to have a better flood analysis or flood susceptibility, every country should focus on high resolution terrain modeling along with the hydrological simulation. So that is basically a combination of civil engineering work is basically on the urban planning department. So they also looking in the waste water management and hydrological simulation, so that we will be able to understand beforehand which are the locations where the water susceptibility will be more. And then we move on to the real-time monitoring data, where I suggest to have more of a synthetic aperture radars data along with some of the deep learning networks, example like ResNet, or we can use the UNet models. So that will help us to understand how the flood extension will be about. So as I previously mentioned, the susceptibility, you can use the decision trees. That will give you the flood susceptibility, but how much is the extension? So for that, I suggest to use an SAR or synthetic aperture radar data along with the ResNet. So that will get you more in terms of flood extension. And then comes to post event, when it comes how we can able to mitigate that. We can use, as I mentioned earlier, we can integrate AI in terms of various convolutional neural networks, CNNs. Examples, we can use the Lab V3 network model. That is a very successful model we have employed very recently for the Himachal Pradesh flood recently happened in India in the month of, I think, in the August. So we have done that, and we have success that model in a better manner, and we could able to present that to the authorities in Himachal Pradesh. So that is something which I also suggest that these ML techniques or ML networks could be employed, and then we could able to achieve the flood mitigation strategies for the country.
Thank you so much, Dr. Saraj. Indeed, to be talk about the model, what you mentioned, like with also AI and machine learning algorithms, I would like to move to the next question regarding like we are living in the era of AI, and how do you think is there a modern application more deeply to go like with the lesson learned and which AI algorithm and application connected with the disaster management can help us with preparedness to with the response phase of the disaster.
Yes, actually, it's interesting, Dr. Sarat, how you're bringing your academic perspective into this technology. Technology booming industry these days with the ML and AI. And I think this is where I believe this is the most value of AI today is bringing the academic perspective into the practical perspective and what we can do and what we cannot do and bringing this scientific aspect of the technology and trying to apply it in real life is the main thing about AI. Uh, Looking on machine learning and AI modules and how they can play a significant role in disaster recovery goes across also multiple things. Engineer Marwa talked about those command and control centers where they connect lots of IoT sensors and different type of sensors. And one of those are computer vision, where satellite imagery is part of the computer vision on that aspect. So if we think about this huge amount of data that is being ingested in real time and not real time at the same time, we have archive data, we have legacy systems that we can take benefit of this data where we can identify patterns and predict scenarios. All this is not possible to do and identify without AI and machine learning. We can do that through high performance computing, but at the same time, uh, doing this with AI is something that will enhance the performance, get better results, and identify things that are not previously possible to do. Uh, so the thing as I was just recapping on that answer that if we focus on the satellite imagery, which is the computer vision of the geospatial remote sensing AI stuff, um, it's very important to have AI models within this computer vision technology because if we rely just on the traditional way of doing remote sensing and image processing, we're losing a lot. Uh, uh, there is a lot of things that we can extract out of imagery data using remote sensing and traditional imagery processing, but with the use of AI models, there's like a new edge that we can open and so we can understand what's going on. Just imagine this imagery on a large scale. How much information is there? How much activity is being done there? And without AI, I don't think we can extract the most out of it. Uh, and that also brings us to the other part where you, Sona, you asked about it, about the historical data. From imagery, we can also extract a huge amount of historical data, up to 10 years, for instance, and use that imagery data in order to identify patterns. And that's all also only possible with using machine learning and AI modules in order to identify specific patterns and be proactive and get more information on what's happening, where are the critical patterns, where are the normal patterns, and where are the unusual patterns, unusual behaviors. Uh, but at the same time, it's very important because we're talking about machine learning, we're talking about AI. It's very important to have the right AI modules with a high performance. And that also brings us to the topic where we need to have diversity of data. And when we say diversity of data, I mean that from different environments of the world. It's not only that we collect satellite imagery from the western part of the world or from the eastern part of the world and then apply it in our region in the Middle East. Uh, Previously, there was not too much imagery data for this region, unfortunately, but for the past 3 or 4 years, we can see that there's a lot of imagery being collected for this region specifically. And that's where AI modules also can be trained more and enhanced to uh, perform better in this region in the Middle East. And I mean specifically in Saudi Arabia because uh, previously we used to have challenge times where we don't have like full coverage of Saudi Arabia. And Saudi Arabia is a huge, like it's a continent by itself. And just imagine if we need to rely on just IoT devices without Earth observation. How challenging it will be to build the right infrastructure in terms of connectivity, sensors to be spread all across Saudi Arabia. It's not like a small city or a small country. It's a continent by itself, and there's a huge areas that lack connectivity because of the desert, because of the terrain, because of the nature of the country.
So it's too much interesting information you shared, and I am just being involved in the topic as a PhD student in digital twin city of Italian city. I'm just wondering, like, having a huge amount of the data, how this AI can help us, like, to integrate them and to help us with the predictive analytics. You shared a lot of information about and I would like to maybe to address this question to Marwa and to ask you, like, maybe to share your experience how AI helped you with disaster management in your project where you've been involved.
Um, well, I can answer you generically. I wouldn't say that any of the project was related to directly the disaster risk management. It's basically risk assessment before the disaster. But when it comes to operation, I wouldn't say we worked a lot on this. But in theory, yes, AI and machine learning, like Engineer Mustafa was mentioning, is revolutionizing the way we process and analyze vast amount of data. This number of data cannot be done with classical techniques. AI is making it possible and opening many opportunities using it. If we talk about disaster prediction, extensive data sets are needed to say that there might be a disaster here. So this includes satellite imagery, this includes weather and climate data, historical data, all this amount of data. AI help you to overlay it and analyze it and help you to predict natural disaster with better accuracy and less time. Machine learning models can help you identify what are the patterns and anomalies that may indicate an impending disaster, maybe like understanding that there is a seawater level rise happening here or a seismic activity. If we talk about damage assessment and response operation in the aftermath of a disaster, AI-powered geospatial tools can rapidly assess the extent of damage by processing high-resolution satellite imagery with aerial imagery, with any inputs coming from sensors or drones or whatever source of data. All of these kind of data, to manage it without AI, it's really a very tough, time-consuming job. So AI is making it possible. The change detection analysis is much easier, faster to do it using AI, and eventually this will help you prioritize what are the area that were subject to damage more and allocate your rescue operations or rescue resources in this area. If we talk about the recovering planning, when you analyze damage assessment or you have all the data related to damage properly assessed, AI will help you prioritize again the rebuilding efforts and the focus area and the areas that you need to avoid or stay away from. Uh, in summary, it will boost the performance. It will give you better and high accurate data that will make things that were taking weeks and months that you can do it in hours or days. And I'm sure Dr. Sarah already has experienced some of these, so I will just hand it to him directly.
Please, thank you.
Okay, thank you, Sona and Engineer Mova. So basically, AI has revolutionized the geospatial technologies currently. So as an academic perspective, so when I'm going to my class, basically we started with what is remote sensing, what is basically the different forms of sensors, and then to give them better understanding of what exactly the technologies are currently evolving. So I prefer to have them project based learning, so I give them different types of analysis assignments to do it in the class. Sometimes sometimes we may run it for a week time to understand more of deeper understanding on the susceptibility aspects. So according to me, there are I categorize them in terms of like prediction. So as I mentioned earlier, I prefer to use LSTM, that is the long short term memory approach, which is basically as a successful one, and we have many research papers published on the prediction aspect of LSTM. And in terms of like damage detection, I prefer UNet or ResNet. These two are, I mean, my students are coming up with some of the things which maybe I am introducing in UNet, and tomorrow they are coming and telling me, sir, it is, we have identified something which is better. That is what how the technology is evolving in these aspects. So I mean, I ask them to do and run it and get more detailed aspects, so that there are different technologies are coming up. So for the damage detection, I personally prefer UNet, but students have come up with more technologies like ResNet. I'm not remembering something which they mentioned recently to me. And in terms of pre-event, like optimized resource planning, they have come up with a reinforced learning technology, and that is actually help us to understand more in terms of resource allocation. Example like what Engineer Mawa has clearly mentioned. After the flood or after any kind of a disaster, how you are able to analyze the damage assessed on a particular area, and how much is the resource which you need to allocate for that particular region in terms of urban planning and development. So that is something which the technology is helping us to reduce the latency and to reduce the amount of time which we are investing on these type of assessments. So currently AI technologies are helping the geospatial engineers to come up with a more advanced prediction rates and the reducing the latency by having more of improvised techniques. And one of the major aspect of LSTM is that we can actually integrate the historical data. That's what Mustafa was explaining. So mentioning that we need to compare it with the historical data, and that historical data comparison and integration of the historical data with the real-time data is possible in LSTM network. So that will actually helping us to understand more in terms of prediction and risk modeling. So that's what I want to say in terms of like how AI technologies are revolutionizing this geospatial world.
Indeed, and as everyone is mentioned again, like it is also important what you are doing, Dr. Sarah, to integrate science and industry, and I believe like in innovation through the research and collaboration, of course. And the last point about the future, like future innovation, what do you think, like how geospatial technology in next 5 years will have the biggest impact for disaster resilience? So
Yeah,
let's
sure,
start with
sure.
Mustafa, please.
Still, there's a lot happening in this industry, and like there's the more that we look at the industry how it's evolving, uh, the more we get benefit out of it. And you can see now, like there is Elon Musk with his SpaceX thing. Is they are just shooting out satellites during all over during the year. Now they own one third of the satellites orbiting the Earth, and you can see that this will lead into more coverage about our Earth, which means more understanding on what's happening in terms of climate change, maybe earthquakes monitoring, maybe gas monitoring, environmental changes, greenery areas, vegetations. all those things. If we talk about the environment, there will be more understanding on our environment and how the earth is changing, and how it will impact us on our daily basis. But at the same time, there's a lot of other things other than the environment, which goes beyond that, which goes into the security of countries, which goes into the security of the global industrial and economic activities, which actually we faced a lot of challenges recently in the region because of the events that happened. But like the more we collect information about our Earth through Earth observation and satellites, the more we will be able to do and innovate and uh, uh, create new stuff and generate more information in order to better understand our ecosystem and better understand our borders at the same time, and maybe optimally enhance our lifestyles if we do it the right way. I can say. But also, Sona, like back to your question about the digital twin and the things that you're doing in Italy. Uh, and the digital twin is a topic that was discussed in multiple sessions in the morning, I believe. It's a very broad topic where one of the good ideas that was discussed is we need to define what are the potential use cases that we need to get out of a digital twin. And only then we can understand what are the information that we need to ingest into a digital twin, whether those are coming from IoT devices, electromechanical systems, satellite imagery, 3D stuff, engineering stuff, GIS data, which is the foundation, which is the truth ground for any digital twin. So there's a lot going on in terms of innovation. There's a lot of things that are being created and made available to us. And again, like geospatial topic is a great topic because it combines between technology and science. And the more you look at it, the more you find that there is huge stuff that can be done with geospatial tools. And it's also good to mention that we're talking about computer vision and satellite imagery, but it's also very important to highlight that there is the human vision, and the geospatial tools will actually what it can do to us as a human. It can help us interpret and analyze better. There's a lot of methodologies in order to do spatial analysis, in order to apply geospatial tools in our daily life. So yes, so there's a lot of interesting stuff coming to our way, especially in the technology and the science aspect of it.
It's such an interesting discussion. So if I would, I see Mustafa has already shared lots of info, and it's really very good to hear from people who are working on the satellite industry. This is invaluable info and experiences. If I will talk to you theoretical about my understanding of what is the innovation coming in place in the 5 years, back to your original question, if we just talk about the high resolution sensors, and we have experts here who might have more detailed or more up-to-date info. If we are talking that the current standard, for example, is around 30 centimeter, 50 centimeter for normal satellite, excluding definitely the military satellites. I've read that expected future standards will be around 10 centimeters. This is very good because it will allow us to have more detailed and accurate monitoring of the disasters. The 30 and 50 centimeters gives you coarse data, so you can't really see much around the damage if you are talking on a building level. It's on a larger scale. So if it is 10 centimeter, it's giving you better or more accurate results that help you identify where the minor changes, minor ground deformation, impending landslides, and so on. If we are talking about innovation in faster data processing, while the current we are saying that it takes several hours to analyze a case, or might take even days and weeks based on the size of the area and the complexity and size of the data you are inputting, whether it's weather data, satellite imagery, land cover, whatever. expected standards will be that integration of AI and machine learning will be with the satellite and aerial imagery. This means that enabling AI-based processing on the satellite, on board of satellites, and there are some few global efforts and global projects and on this. I believe this is a game changer if the data will come to you live from the satellite processed instead of you getting the data and then running the analysis, classification, referencing, and all of this machine learning stuff. It takes lots of time and effort. Imagine it's coming to you straight from satellite, all of this done. This is a game changer, I think so. If we talk about predictive analytics, machine learning models can analyze vast data sets so to identify patterns and predict natural disasters with greater accuracy. This is something that is continuously being developed and growing. So the future is saying that such models will come out with more accurate results and better predictions and so on. And definitely Dr. Saras can talk more about this. This is pure research and development, we would call. If we talk about the integration of drones and ground sensors, the current case is, yes, there are some ground sensors and drones, but their deployment is often limited by regulatory and logistical challenges. So they are not spread as much as we wanted, and the output is not as much integrated with the geospatial data or the digital twins as much as we want. They expected in the future that these challenges will be resolved, inshallah, and that the use of drones will be equipped even with advanced sensors and will become more widespread, providing detailed views of the affected areas that satellites might miss, because satellite data, it's not coming to you every hour. Yani best case scenario will be coming to you every day if it is a bit of course output. So yes, ground sensors will be more extensively deployed and overcome the current challenges to be continually monitoring urban and environmental challenges and feeding you with this. If I go back to the last bit of your question, which I think is the most impactful of these, again, I think that the AI-based processing directly on board of satellites will revolutionize the disaster resilience by enabling real-time data coming to you filtered, compressed, and ready to use and ready to be an actionable information. So yeah, I think these are my thoughts around this, and yeah, thank you.
Thank you so much. And considering our time, and I would like to ask Dr. Sarat for his input. Otherwise, I have a lot of questions to discuss all the day. So please, Dr. Sarat, thank you.
Yeah. The thing is, like, more of changes which I'm mostly expecting in the geospatial technology is basically in terms of what engineer Mawa has mentioned about that, you need to have, like, 10 centimeter apertures, and then that is basically the granular disaster assessment that is actually happening, and there are more companies are mostly running into more of a payloads into getting it of a 10 centimeter things, and more of 10 and 5. There are certain companies which are currently doing the research into that field. Examples like, graph neural networks, which we have not heard about that, and that will help us to understand more in terms of a disaster relationship between the countries, and more in terms of, we have discussed this approach earlier when we talk about the Dubai's flood. That is about the federated learning approach. It is not like, Dubai municipality or the urban planning department or the geostationary or the space agency which will be having the satellite imagery information. It is not like that. It is to have a collaborative effort between the federated government bodies, which will help them to integrate this information and to, have more of advanced prediction things. That is what going to happen, and especially UAE is more focusing in terms of having more of federated learning approaches in almost all fields. And moving further, we can have, like, integration of IoT, which has been mentioned by Mustafa and engineer Marwa, which is basically of not only on the satellite, which I would like to prefer in this. Sometimes we need to use the social media streams also needs to be integrated, because on ground we are not able to get such of the data, because some of the people which are on the ground may have released some of the data, so that can also be integrated into the data which we are having, so that we can have more of ground based research, and that we can help us more accuracy into our data integration. So that is what mostly I'm expecting more in terms of high resolution imagery, which has been about 10 centimeter, or else which I can say mostly in terms of a granular disaster approaches or the assessment. That's what I'm expecting in the recent coming years.
So,
Thank you.
yeah, thank you all again. And I think you covered very well, because I don't have any question. Thank you again. So it was really, really nice to hear that details, and thank you again for your valuable contribution. So now we have to jump to another session. So thank you again for timing and
Thank you.
participation, GeoSpatial Next. So
Thank you,
Thank
everyone.
you.
thank you.
Thank you.
Thank
Bye.
you.
Thank
Thank
Thanks a
you.
Pleasure
lot.
meeting you.
Bye.
Thank
Bye.
you.
Thank you
Bye.
again.